Okay, lesson number 5, equations of circles. Consider a circle with a center at 4, 2 and with a radius of 5. Show that the points 8, 5 and 1, negative 2 must both lie in the circle. So what we're going to do here is we're going to give ourselves a rough sketch of a coordinate grid, right? We're going to plot our center 4, 2. So we're just going to make some rough sketches, right? 4, 2. There's our center. 8, 5. Somewhere over here. So we've got 8, 5, 4, 2, and then we've got 1, negative 2. So these points are on our circle, so we're just going to roughly kind of draw a circle there. So we have to show that they are on our circle, that these points are actually on the circle, and the radius is 5. So this distance from 4, 2 to 8, 5, that's a distance of 5. It has to be. They're telling us that radius is 5 there. Now, what we're going to do is we're kind of just going to make a right triangle out of it and make sure our Pythagorean theorem works. So from this 4, 2, right, we would kind of go straight over to the right. So we're going from an x of 4 to an x of 8. So that's a distance of 4. And then a height of 2 up to 5, that's a height of 3. So technically 8 minus 4, that's why this side's 4. If I subtract the y's, 5 minus 2, this height is 3. So now does 2 squared plus, does 3 squared plus 4 squared equal 5 squared? 3 squared plus 4 squared equal 5 squared. So does 9 plus 16 equal 25? Oh, and it does. 25 equals 25. Since that works, that means this point is on the circle. So this process just gets repeated for the other triangle as well. So again, this would be another radius here, and this radius again would be 5. I would be going from an x value of 4 to 1. And remember, you can subtract your x's here. So you just subtract, right? 1 minus 4 or 4 minus 1. And there's your x value of 3. And you'd be going, subtracting your x's here. 2 minus negative 2. There's 4. And it's the same exact triangle. So it's a 3, 4, 5 triangle again. And it's 3 squared plus 4 squared equals 5 squared. And this again would work. It would give us 25 equals 25. So that worked beautifully. We were able to check our points by technically subtracting our x's to get our x distance, subtracting our y's to get our y distance, and setting it equal to our hypotenuse, right? So we subtracted our x's, squared it, subtracted our y's, squared it, and our radius was squared. So look at the next question. Given that xy is an arbitrary point on this circle, write an equation for the distance this point is away from the center regarding the equation so that it contains no radicals. Well, my friends, to do that, it's just what we talked about above, right? We would just take this x right here and subtract our original x. And what was our original x from above? It was 4, correct? It was 4. So I would just do x minus 4. And I'm plugging into the Pythagorean theorem, so squared equals, that equals plus y minus, our y value is 2 at our center. So y minus 2 squared equals, and our radius squared was 5, or our hypotenuse. So we subtracted our x's, squared them, subtract our y's, squared them, equals our radius squared. And that's super interesting. That's very interesting, this formula that we just came up with. Because take a good look. Inside this parentheses is a negative 4 now. Look above. What was our center at? Positive 4. So the signs are different, right? Look at the y value, negative 2. what type of y did we have? A positive 2. So both of the signs on the inside of the parentheses are switched to getting the center. And if we were to square this out right here, right? What's 5 squared? 5 squared gives you 25, right? And how do I go from 25 to 5? I square root this number on the end. So this is how we can come up with our equation of a circle. A circle whose center is anywhere, let's just call it h and k, and has a radius of r, the equation is going to be x minus h squared plus y minus k squared equals r squared. And these in here can be pluses, and these in here can be minuses. So these signs in here can be pluses and minuses. Each parenthesis should be squared, and it's going to equal radius squared. So right now you might be thinking like, Mr. Woods, what the heck is going on? I got all these letters going on. What does this mean? All this means is, hey, they're going to put a number here at h, and they're going to put a number here at k, just like you had a moment ago right here. These numbers. All you have to do is take these numbers and switch their signs, and it gives you the center. You have to take this number on the end. Be careful. They squared this number. So you have to square root it, square root of 25, and it gives you the length of your radius. So just for fun here, do not write this down. I'm just going to show you if I were to do this, x plus 2 squared plus y minus 8 squared equals 16. Just by looking at this, you can say, hey, this circle right here, the center is at -2, +8. So all you have to do is switch the signs, and that gives you your center. Your radius, just take the number on the end, do the square root of it. What's the square root of 16? 4, and there's your radius. Okay, so this number, this radius, when you square it, it designs the number on the end. So going into your examples here, on the next page, example number 1. So example number 1 says, a circle has a center at -5, 7 and the radius of 3. Write the equation. So I'm setting up my parentheses first. Right, blank parentheses, nothing in them. And my x has to be a -5, so in this parentheses should be a +5. My y value needs to be a +7, so this y value should be a -7. And at the end, all you have to do is take this radius, right? Take the radius, watch, square it. What do you get when you square it? 9. So when you're creating the equation, you have to square the radius to design this number. Because if I were to square root 9, what would you get? 3. And there's your check. Here's another example, example number 2. A circle has a center at 0, 4 and a radius of 2. Write the equation of the circle. Well, I'm setting up my parentheses and I'm plugging in. Well, I'm not plugging in anything for 0, so that's 0. My y needs to be a positive, so in here is a negative. My radius is 2, so I'm just going to take 2 and I'm going to square it. What is 2 squared? 4. Now, if you want to write this in a better format here, you're going to write it like this, x squared, because there's 0 for the x's, and everything else stays the same. And there you have it. So look down below here. What I want you doing is I want you, for each of the following, state the center and the radius. So I'm going to do the first 2 here with you. So here, your first center. This is very quick. Switch the sign, 5, switch the sign, +2. So negative, negative becomes positive, positive. To get the radius, square root the number on the end. Square root of 25 is 5, and that's it. Repeat this process. So the center here, +4 becomes -4, -1 becomes +1. The number on the end is 100, so the radius is square root of 100, which is 10. All right, so I want you guys to finish these really quickly. Whoever is filling in for the period, please just pause the video for like a minute and a half. That's all this should really take. And 2 minutes. Ladies and gentlemen, complete these problems. Go ahead. Go, go, go. So coming back, ladies and gentlemen, very quickly, your center for this top right problem is 0, +3. And the radius here is radical 15. It's not a perfect square, so I'm leaving it. Going down to the next 6 problems, my center here is -4, 0. Radius is the square root of 16, which is 4. Problem in the middle, the center is 0, 0. There's nothing with the x's and y. The radius is the square root of 9, which is 3. The center here is -2, -5. Switch both those signs. The radius is the square root of 81, which is 9. And on the bottom row, center is -1, 0. Oh, sorry, -7, 0. The radius is the square root of 1, which is 1. And the center is 1, -4. Radius is the square root of 14, which stays the square root of 14. It is not a perfect square. And your last one here, the center is -10, -9. And the square root of 64 is 8 for your radius. And now you are going to go to your homework here. So for the homework here, you are going to write the equation out. So just like we did in class, for these first two, you are writing in the equation and then just sketching the circle. So plot the center, go a radius up 5, right 5, down 5, left 5, and just sketch it in. And that's all you're doing for these two. For number 3, which of the following represents certain information? For number 3, you should write out the center and the radius and then design your equation. Right, so write out the information first and then design. Number 4 is just like you did earlier with the graphs. Write out the center, radius, graph it. Write the equation, graph it. And number 6, pull out the information. And number 7, write the equation of a circle. You might have to use distance on this or Pythagorean theorem. That's it. Good luck. Have a good weekend. Oh, never mind. See you tomorrow.